Hi guys, this is John Hashmet and welcome to Physics Simply. In this video we'll be seeing the effect of placing a current carrying conductor inside a magnetic field. It was found that when you switch on a current inside a conductor which is placed in a magnetic field, you will find that the wire that's carrying the current starts to move. This is because there is a force on the conductor. But when you switch the currents and switch the polarity of the magnet, you'll find that the force changes direction in a certain way. In this video, we'll be learning how to predict the direction of the motion of the conductor inside the magnetic field, and we will be explaining why there is a force in the first place. So let's go.
If you place a wire carrying a current, for example, connected here to a positive voltage and here to a negative voltage, if you have a current flowing inside the magnetic field, which is here pointing to the right from north to south, this wire would experience a force, and this force is in a direction which is perpendicular to the magnetic flux and perpendicular to the current. The reason that you have a force is that you have two magnetic fields superimposing on over each other. So the wire has the circular magnetic field, and the magnets or the magnetic poles have their uniform magnetic field, and those two fields are superimposed over each other. Whenever you have two magnetic fields superimposed on each other, you experience a force due to variation in the flux density in different areas. So in which direction is this force? So the way you know the direction of the force is Fleming's left-hand rule. How to use Fleming's left-hand rule? Simply by pointing three fingers, the thumb, the first finger or the index finger, and the middle finger in perpendicular directions. So you have the thumb pointing, in this case, vertically, index finger to the right, and the middle finger is pointing out of the page. So let's apply this to the case above. You have the magnetic field pointing to the right. So basically the first finger is the magnetic field. The thumb is pointing towards the motion or the force. And the middle finger is the current. So the thumb is the force. The first finger is the magnetic field. The middle finger is the current. So if you apply this to the image above, you would find that for a field pointing to the right and the current coming out of the page, the wire would experience an upwards force and the wire would start moving upwards until it goes out of the magnetic field. Then the two magnetic fields will no longer be superimposed and the force will no longer be there. So how to use the Fleming's left-hand rule in different situations? For example, here you have the two poles oriented in the same direction, so the field is still to the right, but you may notice that the current has reversed its direction. Instead of pointing out of the page, it's pointing into the page, which means that you would have to point the first finger to the right, but you have to change the orientation of your middle finger to be pointing into the page. You would find that the thumb is pointing now downwards. So this wire will experience a downwards force instead of upwards. So basically, if you reverse the current, you reverse the force. Okay, what then if you've reversed the flux direction instead of the current? So you'd still have the current pointing out of the page, but the magnetic field now is pointing to the left. You would find that it's very difficult for you to point your hand, your left hand to the left and still be inside the paper or within your working area. So what you do is you can just flip the whole page or the exam paper. So for me here, I'll just select the image I've drawn and I'll just flip it for you. You'd rotate the whole book or the exam paper. So now the field is pointing to the right. And I remember that the current was out of the page, so I would just keep my middle finger out of the page, pointing out of the page. And now the magnetic field is easy. It's to the right, and the force is pointing upwards. So I would just draw the direction of the force upwards before I return the page to just reserve what I've done. And now I can return to its original orientation, and voila. Now the force is downwards. So basically, if you reverse the current or the flux without reversing the other one, you still get a reversed force. Okay, so what happens if you reverse the current and then reverse the flux? Basically, you're reversing 2 times, so you would get the same direction of the force. So for example, in this orientation, you have the field is pointing towards the right. If you reverse it to the left, you get a downward force. And the current was pointing out of the page. If you reverse the current after reversing the field, the force will be reversed again, so you'd still have an upwards force. Okay, another type of image that you may get is a field going into the page, like the one shown on the left here. Here you have a north pole towards yourself and a south pole in the depth of the page, so the field is going into the page. What you would do is you point your first finger into the page. If the current is pointing to the right, you'd find that you would expect to get an upward force. If the current is moving to the left, you would get a downward force, and still the field is pointing into the page. Okay, what if the field is parallel to the page, upwards? So here you have a north pole on the bottom, a south pole on the top, so the field is going upwards. So you would point your first finger up the page or parallel to the page. If the current is going to the left, then the force is going into the page. If your current is going to the right, then the force is coming out of the page. Your thumb is pointing out of the page. Here the thumb was pointing into the page. So these are some examples of how to use the Fleming's left-hand rule. You can pause the video now and go back and try to orient yourself or get familiar with how to use or rotate your hands in different positions. And whenever you feel that it's difficult for you to rotate your hand, just flip the page or rotate the page until you feel comfortable with using the Fleming's left-hand rule.